Welcome to Ask and Learn.
In this video, we are asked to prove two statements which is similar. So if we have a poset and a set inside that, if least upper bound exists, it must be unique. That is, it can be only one of them. And the same goes for greatest lower bound. So we're gonna prove one statement, and the other we can also use what we have proven to prove it without like starting over from scratch by using the property of a dual poset or a dual relation, if you will. So if we have a poset with relation R, we have a dual of it as SR prime by reversing every pair in R to get R prime. We're going to use this, but let's talk about that later. First, prove the first statement. So let S be a poset and A be a subset of S. Let U be a set of U1, U2 like this. It can be infinite. It can be empty. Let U be a set of upper bounds of A. So U is also a subset of S. Now suppose that we have Ui and Uj as least upper bounds. So both of them are least upper bound. Then by the definition, we will have the property that Ui is less than or equal to everything in the set U. And that's also true for J. Uj will be less than or equal to everything in set U. All right. When that happens, we will have this two statement Ui less than or equal to Uj and Uj less than or equal to Ui. But this under a poset, it has anti-symmetry properties. It means Ui and Uj must be the same. And so we have shown that if least upper bound exists, there can be only one because we assume two things, but they end up be one thing. Okay, and that is how you prove it. Now for the dual poset statement, so we start off by saying that the greatest lower bound, which is what we want to prove, of a set A under a relation R that we start with, is also in fact the least upper bound of the set A, the same set, but under the reverse relation. If you think about it a bit, you will see that this is the case. We just reverse greater or lesser sign, right? Everywhere. And so the greatest lower bound become least upper bound. So to show that greatest lower bound is unique is the same as to show that least upper bound is unique, but we already show this. And the duality of relation doesn't matter because when we prove this, we prove it for any relation. So R prime also count, right? So we don't specify any relation for a poset. And that is it. We have proven both statements. Thank you.